If you're looking for a real-time oracle that gives you access to thousands of different markets, then let me introduce you the new Morpher Oracle. It is an intent-based, real-time, low-latency oracle that is currently live on Polygon. It gives you access to thousands of different markets, from stocks, commodities, indices, and of course crypto. And together with me, you're going to convert a smart contract to use the Oracle data in this video. Before we start with the coding part, let me show you the final app we're building in action. On this page, you can mint one NFT. That NFT represents an ounce of silver, so you can buy it for the price of an ounce of silver. It is not a delayed price or an approximate price. It is the live spot price of silver in POL token on Polygon. Once minted, you can look at it on OpenSea or admire it in your ERC-721 safe wallet or do anything else with that NFT. The price gets stored as a trade for this NFT. Together with this guide comes also a written tutorial that has everything step by step for you to follow along. It starts with the finished application, so you can give it a try, and then you find all of the different steps that are necessary to finish this project in a step-by-step manner, following along with this video. The video itself is recorded in 4K, so please make sure that you select the right resolution for your monitor so everything will be nice and crispy and easy to read. And open it in a separate tab so you can follow along and don't have to switch back and forth. Now, let's have a look at what we're actually building. We're going to build this kind of website with this functionality. We're going to build the website using Next.js and RainbowKit as a starter template. Then we are going to switch over to build out an ERC-721 token using OpenZeppelin's templates. Then we are connecting everything together using the data dependency of the Morpher Oracle to mint one NFT for the spot price of silver. That's the live price. And we are going to do this on Polygon. For the website, we are going to use this kind of template. It's very easy to get started with, and we are going to have everything that we need to connect our wallet to get into the Web3 world. Then we are going to use this template builder from OpenZeppelin or this wizard to build out our token. We are going to use the Morpher Oracle data feeds to get the spot price of silver and the current price of POL to calculate how much value needs to be sent to the smart contract to mint one of those NFTs. The NFT is a real NFT that is going to be visible on NFT websites such as OpenSea. And as a trade, we are going to store the purchase price. So the price of silver at the time of purchase will be stored as a trade. We're going to have a nice logo and a description, obviously, and everything will be on Polygon. So for you as the viewer, it's also visible what is happening here. For the video, I'm going to start with a completely empty project. I'm going to install that website template, and I'm going to switch over to the Foundry contracts. We are going to add in our OpenZeppelin contract, and then we are going to see how we can unit test those Oracle calls and then deploy everything. And then we're going to finish up the website, polish it, add in the smart accounts, see how much funds we have, add in Oracle data preview so we know how much we need to send along, and then obviously do the minting. Now, let's get started. In this case, I want to get started with the RainbowKit template. And when you start with npm init at rainbow.me/RainbowKit latest, then you just have to enter a name, and I'm going to name this follow-along demo because it's our follow-along demo. And I'm going to speed up installation of the dependencies. When the dependencies are installed, then you can simply type in npm run dev and you get this dev server where you get a very simple page. It's more than enough for our purpose here. You can connect your wallet. I'm using MetaMask in this case. And the last thing I'm going to do before moving on to the contracts for now is just committing everything to this Git repository, creating a new folder called contracts, sitting into the contracts folder, And now we are going to take care of our contracts first with Foundry. Let's get started by initializing a new Foundry project. We do this by just simply typing in forge init. This one will initialize this new Foundry project into the contracts folder. And in there, you will get a starter project from Foundry. It will include this counter example with some tests and a script, and a lib with all of the Git modules that are added as libraries. The counter example is very simple, and we're going to delete this later on because we want to add our NFT in the Git modules. There are all of the Git repositories that are added through Foundry install, and we're going to add two of them later on. That is the OpenZeppelin contracts and our Oracle or ERC-721 Oracle repository from Morpher. Then there's the Foundry toml file, which is the configuration of the Foundry project. And in the git ignore, you have a couple of things already ignored. We're going to talk about these a little bit later, because right now we want to add our OpenZeppelin contracts. If you head over to openzeppelin.com/solidity-contracts, you find the contracts wizard. First of all, we're gonna need an ERC-721 token. Let's make it mintable and also auto increment the IDs. So every time a token is minted, it gets a new ID, and then the rest we can leave at the current settings and then give it a name. I will call this one maybe silver ounce and give it a symbol such as FXAG. We don't need a base URI for this one because we're going to generate the trade and the metadata on the fly with some inline JSON. And that's it. Now we're going to need to remove all of the current existing counter Solidity contracts in script source and test. So we can basically just type in rm source counter s, script counter, and test counter. Then we create a new file, just call it silvernft.sol in the source folder, and paste in the content of the wizard. And you see here that our OpenZeppelin contracts, the imports are not resolving. First of all, we need to install them. For that, we need to commit our current changes, add them with Git and commit them because Foundry is Git based. And then we can install the OpenZeppelin contracts. So there's nothing to commit. And then we can simply type in forge install OpenZeppelin/OpenZeppelin contracts for the repository. So we will download this repository and install it into the lib folder. I can show you that here. They're here now, but they're still not resolving. And the reason is that the OpenZeppelin wizard is actually made for node modules based projects. And you can either do a remapping with this remapping.txt, or you simply change the imports to reflect what's in the lib folder. And I'm going to do that now. Instead of add OpenZeppelin for the node module, I'm going to replace that with OpenZeppelin-contracts for the contents of the lib folder. Now everything is resolving and we can build our project. You can see here the build artifacts are in the out folder and in a folder called silver NFT for our file name, and then silver ounce for the contract in the file. And next we are going to add in our ERC-437-Oracle repository to get access to the contracts for the data dependency. So we're going to commit everything again just to have a clean repository here, so we can install things from or with Foundry. And then we can type in forge install morpher-io/ERC-437-Oracle. what will happen here is our Oracle will be installed into the ERC-721 Oracle lib folder, and then we can add in our dependencies for our NFT, so we can actually grab data from the Oracle that gets injected on chain. All right, now we have everything here. Let's add in our silver NFT, the ERC-721 Oracle data dependency contract. We'll show you in a second what that does. So ERC-721-Oracle/source/data dependency dependent.solidity file. And when we open that up, then it's a very, very short contract, an abstract contract that just defines one function that needs to be defined by our contract. That is the requirements function. And that one is here to tell our Node.js library what kind of data is our contract expecting? What kind of data feeds does he want our Oracle to inject during that user operation? So I'm going to copy this over, and you're going to see that in a second when we're going to do the unit testing for our smart contract, how that actually works. It's going to be a requirements function, and it takes a data requirement, or it takes a function selector, and the Node.js library will ask the contract, if I'm going to interact with this SafeMint function, do you need any data? And the SafeMint function is a SafeMint address signature, and it will need 2 data points. Data point number 1 is our commodities silver feed, and data point number 2 is the Pol US dollar feed. So it can actually calculate those 2 together and then see if the message value is enough to accommodate for the price of silver in Pol token. So I'm going to define here an array with 2 elements. Requirement number 1, the first element of the array, is going to be at the data provider. I'm going to show you this in a second. For this particular contract, the price of the silver market. And the second requirement is, again, for this data provider, which is currently Morpher. For this contract, the price of the Pol market. Both are denominated in US dollars, and we're going to return this requirement. And if the function selector is not SafeMint, then we just return no data requirement. The array is empty. Now we need to define those. The data provider can be different than Morpher. Currently there is only Morpher because we just started with the Oracle. But if there is more data providers, everybody can become a data provider, then the address of the data provider would change. So we're gonna define this during the deployment of the contract, which one is the data provider that this contract is using for providing data. And you can get our data provider address in the feed section of our website, oracle.morpher.com/feeds. There you find the data provider for our current endpoint and addresses section. And the other thing that you need is the Oracle entry point. That one will most likely not change, and it is always the same for every data provider where data is provided for a specific data provider. That's the 2 addresses that you would need. You can either hard code them, or you can, like I do it, provide them as an argument into the constructor of the contract. The other thing that you will need is the feed ID. The feed ID is a Kesa cache of the actual data feed. And the data feeds for Morpher are prepended with Morpher, double point, and then the actual feeds of that we have in our system. So for example, Morpher double point commodity _xag would be the feed for silver. And then you have the feed for Pol. That would be the feed for Pol USD. Ideally, you make these dynamic, so they are not hard-coded. And the reason for that is, for example, they can change. Like Matic became Pol, and we would rename the feeds, so you can also rename them. And I will also show you later what is the actual issue if you make them hard-coded. It's always better to make them dynamic. Maybe you spotted it already. So this would be another thing that I'm going to show you now is in the data dependent, there is a function called invoke Oracle. And this function is going to return a response with expenses. So if you ask this function for the Oracle, for the provider, for commodity silver, give me the current price and give me how much it costs to actually get this data point. And that's what we are going to do now. So we can use our SafeMint function that users can actually send money there in the form of a payable function and then actually mint an NFT for the current price of silver. So the payable, the message value must be at least the current price of silver divided by the current price of Pol plus the fees it costs to actually get these values, because reading, like using the Oracle is not 100% free. It can cost something. That's up to the provider to set the fees for the different data feeds. So when we want to get this response with expenses from our data dependent contract, then all we have to do, for example, for silver, is use this invoke Oracle function and give it the Oracle entry point, the data provider that we actually want to use, and of course the feed ID or the market ID, which we want to use it for. And this invoke Oracle function will take care of taking the Oracle response, which is encoded, hex encoded, and decode it and populate this struct response with expenses and then give it back to us. So it will call this function, make sure the timestamp is correct, pay for the data, and give us back this struct here. We do the same thing for Pol. Market Pol. And then we need to require that the message value is greater or equal than the expenses together for silver and Pol, plus the actual value of silver in Pol token, because we are on Polygon. So we take the response underscore XAG value divided by the response underscore Pol value times 1 to the power of 18 to actually get to the gas token in the smallest denominator. It's way on Ethereum. I'm not exactly sure what's on Polygon actually. Otherwise, we are going to, well, the require will just error out and it will give us back an error that it's not enough value. Great. Now, because we might have sent along a little bit more value than actually necessary, we're going to refund the remainder. And we're going to calculate this the exact same way as we calculate the require statement here. As you can copy and paste this over, or you calculate this in a separate variable. That's entirely up to you. And then we are going to refund the message sender the remainder. However, be aware that you want to do this as the last operation for the checks, effects, interactions pattern. The next thing that I want to do here is store the token price, the price in silver, because we said we want to have this one trade for our NFT that actually shows the price of purchase, the spot price of silver at the time of the purchase. So I'm going to create a new mapping, and I'm going to map that from the token ID to the actual price, so from a UNT256 to a UNT256 for the token price in USD. It's a fairly simple and straightforward mapping. Get the token ID and store the response XAG value. So in this case, it's just going to be the silver value in US dollar, not the not normalized to the pole or gas token. So this one is last because of the checks effects interactions pattern. And then I want to do one last thing here, that is just refund everything, because it's just a demo contract. So we are not going to take any money for that. I'm just going to send whatever is left in the contract to whoever used the save mint function last. Should be always empty anyway. Now, obviously, this one you don't want to do in your contract when you're handling with money. Great, now we have that. Now we also need to take care of our inline JSON, as I mentioned before. And there's this token URI function, which takes a token ID. And normally it will return a URL for the JSON where the token metadata is stored. But we can also return inline JSON over here. So the requirement is simply that the token ID is already in use. And then I will just give you this JSON that you can use. It has a small little icon. The icon was generated by ChatGPT actually. So there's a name, a description. The attribute is our token price in USD, the one trade, and the image, and obviously the external URL is our Oracle website. Great. Now that we have this out of the way, let's commit our changes. So we have a clean repository. And let's see how we can actually write a unit test for our NFT. Create a new file, silver nft.t.sol, and let's get started. In our next part, we are going to talk about how to unit test these smart contracts. And if you're creating a unit test, and we will create one in a second, there's two options you have. You can either fork what is on Polygon and override what is in the entry point, or you just create a very self-contained unit test, and I prefer that quite a lot over forking, where we create a new Oracle entry point, and then we set the Oracle fee, so it actually costs something to get data. Then we write the data for silver and pole as the Oracle, and then we just test if minting works. So that is the process, and in the next part of the video, we are going to do that. Writing a unit test for the Oracle is a little bit tricky. So there's two ways you can do that. Number one is you can fork whatever is on Polygon right now, and then basically override what is in the Oracle entry point smart contract stored as the data for the smart contract. Or you simulate the deployment of one of the Oracle entry points, and then you are going to simulate signing a message for the Oracle entry point to override the data, to write the data point, and then read the data point again. And that's exactly what we're going to do here. We are going to import the Oracle entry point from our ERC-721 Oracle repository. And then we are going to deploy the Oracle entry point. And as the Oracle, we are going to set one of the data points for silver and for pole tokens. And then we are going to read out this data when somebody wants to buy an NFT from us. So I'm going to import here the Oracle entry point and the data dependent smart contracts. And then I'm going to write my test smart contract, my silver NFT test smart contract. This one is a standard test setup from Foundry. If you start it like this, there's no tests to run. And then we are going to write our setup function. In our setup function, we have to first create the Oracle entry point, and then we are also going to set some pricing information or some price points for actually requesting data from our Oracle. So we can test both. We can test if the data is read correctly from our smart contract, and we can also test if our Oracle is getting paid correctly. Now we're going to define a new Oracle instance. Then we are going to set some data provider. So we're going to use the make account function from Foundry to create a new account. And then we are going to create our silver NFT smart contract. And that one needs 3 parameters. It needs the provider, it needs the Oracle entry point, and because that's the new contract, it also needs the address of the owner. Now we are going to set the price information for getting a data point from our Oracle smart contract, and that one relies on a signature schema. And in this case, as you probably know from the signing method from Ethereum, there's a prefixed message, and for our Oracle we also use a prefix message that is an Oracle signed price change and a 148 bytes message that is the chain ID or the KZAC hashed of the prefix, and then we have a couple of parameters, the chain ID to avoid any replay attacks on different chains, the provider address, the Oracle nonce to provide replay attacks on the same chain, what kind of market it is for. And over here you could use the KZAC hash of crypto, Morpher crypto poll, or in this case I'm just going to extract it from our silver NFT contract. Or you could also use the KZAC hash of market, double point, crypto poll, and then you would also define the price for getting the data. So in this case, we define getting this price is 0.001 ETH or POL or whatever chain you're on in gas tokens. Now we need to sign it, and we get back the uint8v and then 2 bytes 32 RNS from the signature. We use VM sign, and we use the provider private key to sign this prefixed hashed message. And then we need to send off a transaction to our Oracle entry point. I'm gonna additionally prank here that the sender address is the provider address, and then we are going to call Oracle set price to set the price for this provider, for this nonce, and then for this market, for this price, and then we provide the signature. Now if I run this, it won't do much, so we need a test function to actually call the setup. And in our test function, we are going to, well, first of all, warp a couple of blocks, so something actually happened in the meantime. And then we're going to specify for each of the data requirements from our silver NFTs mint, safe mint function. That's going to be the bytes for KZAC 256 of the safe mint address for each of the data requirements that is returned there. And we already know it's going to be 2 requirements. So we have 2 prices for our safe mint where we know that it's going to need 2 prices. We have the price of the precious metal, and then we have the price of POL. And then we basically set everything in a for loop. I know for loops are not the best choice for Solidity, but since we are here in the test environment and we have an upper boundary of 2 or 3 or maybe 4 elements in the for loop, I think it's safe that we can use this for loop. Now we're just going to make sure that the provider set by our NFT contract is really the provider that we are going to use. And then we're going to put together this value. Now that's a little bit tricky because we have to do some byte shifting. First of all, we take the block timestamp and multiply it by 1000 to get it in milliseconds. And then we're going to shift it by 26 bytes to the left. That's the first 26 bytes. And then we're going to add in our decimals. That is 18 decimals for the value. And then we're going to shift that by 25 bytes to the left. And then we add in our price, which is a uint, which goes into the last piece of the value. And then we're going to sign it again. This case, we're going to prefix it with an Oracle signed data op. And then it is a 168 bytes message. It's again the chain ID and all the other parameters that are necessary to actually sign this message for the Oracle. So we have the chain ID. We have the provider address that is going to create this data. Then we have the nonce, so we are not going to have replay attacks. Then we are going to set this for a target smart contract that can read this data. And then we are going to set it for a specific market, and then the actual value as a bytes 32. Now we need to sign this again. We get VRS back. We are going to use the provider key and the prefixed message. And then we're going to send off a transaction with the provider address again to this time oracle.storedData. A little bit of formatting, and we are there. Now for the last part, we need to actually read the data. And to do that, we are going to simulate some person, Alice, is going to buy one of the NFTs for the right price. Now we're going to create a new address, and we're going to use the same make address function from Foundry. Then we're going to give Alice a couple of ETH, and then we're going to start pranking with the Alice address. And we are going to call the SafeMint function, but we are going to send along a value. And the value must be the amount of silver. Now here, it's actually from gold. So I did a previous example in gold. It's obviously $35 divided by the 0.4 plus the data price. So we have 35 divided by 0.4, that is 87.5. That's the amount of ETH or gas token that we need to send along, plus the 0.01 ETH for gas token for the data. And we are going to mint this for Alice. And then we're going to assert if Alice really has an NFT with the silver NFT.balanceOff function, and just make sure one NFT was minted. Save it, run forge test, and let's see, it's passing. Now let's make the reverse. Let's see if it's really failing, if we don't provide enough. And to our surprise, it is also passing. So something was wrong. And this is why it's so important to get to the unit tests, because there could be a spelling mistake or something. And we can see here, we have actually a spelling mistake in the selector. Now we have fixed that. And let's see if when we provide the correct amount of ETH, that it actually passes. And yes, it does. Now let's go on and see how we can deploy this smart contract. Now that we have our unit test, let's talk about how we can deploy this. And for this deployment, I want to use Forge script because I think it's much better to have a scripted deployment process. You can also use Forge create with this very simplistic smart contract. Both work equally fine. I just prefer using Forge script for this one. So we'll create a new script. Then we'll get the provider and Oracle entry point from our Oracle website. I'm going to show you that. Then we're going to create a private and public key pair, which we're going to fund. We're going to need an RPC endpoint to actually send the transaction to. I'm going to show you where you can get one, and we will also take care of verifying the contract on chain. So without any further ado, let's get started. To deploy everything, I like to use Forge Script. There is also Forge Create. We basically just provide an RPC URL and a private key, but that's not what I want to do. I like Forge Script a little bit more. But before we're going to do that, let's just commit all our changes to our Git repository, git add, git commit. And then let me open the scripting section of the documentation. So in Solidity scripting, and then as you can copy this scaffolding thing over and create a new script in the script folder, silver nft.s.sol, paste everything and replace the contract imports for our silver NFT. So we have silver ounce, and then it needs a couple of parameters, the owner. Let's set this to the message sender for now. And then we also need the provider address, and we also need the Oracle entry point. And you get these two addresses from the oracle.morpher.com site, or the documentation, currently in the feed section over here. And you can copy these over. Now we have that. We also need a private key for deployment, an RPC URL, and if we want to verify our contracts, we need the Jiffyscan API keys. And then we can use this call on the command line. So where do we get the private key from? I personally like to use a tool called VanityEth. You can use anything else that you want, and it creates me an address and gives me a private key. It's directly on the command line. Then for the RPC URL, I'm just going to chainlist.org and copy the Polygon RPC, whatever is healthy. And for the API key for Polygon, you have to sign up to Polygon Scan and get an API key from the account section. Now with all three things here, we have to fund our account that we're going to use to send transactions from. I'm just going to provide one Matic there, or one poll is it now. And then we can run the Forge script. Before we do that, we have to source.env to get this into the environment files, and then Forge script, chain ID 137 for Polygon, then our script that we have in scripts/silver nft.s.sol, our RPC URL from the environment variable. We're going to broadcast it, we're going to verify it, and our sender is our address here. So the message sender in the script will be that address. And then we basically just run it. And what's going to happen is it's going to simulate this transaction. Then it's going to send this transaction if the simulation is correct. And then it's going to verify the contracts. And we can open it on Polygon Scan. And we see that our smart contracts are verified. We add everything to our Git and we continue with our website. Now that we have our smart contracts, and I think you have a pretty good understanding how things work, I want to speed up our video a little bit and talk about our Next.js app. So we are going to install Tailwind, and we are also going to install the Morpher data-dependent account abstraction kit, which depends on Candide. Then I'm going to introduce the use account hook from WagMe. Then we are going to calculate our smart account address. Then we are going to use the use balance hook to calculate how many gas tokens are in there. Then we are going to use the use send transaction hook to very quickly send some value to our smart account address, so we don't have to open our wallet for that. And then we're going to use the use read contract hook to calculate how many NFTs are actually in our smart account already minted. Let's get started with our Next.js project, and I'm just going to start the dev server. And one of the first things that I want to change here is install Tailwind CSS. But before we're going to do that, let's remove all of the chains that we don't need. It's in WagMe TS, and I'm just going to remove everything that we don't need. So we are just left with Polygon, essentially. Also remove the imports. And when we reload the page, the selector is gone because there's only one chain. Now let's get started with installing Tailwind CSS. It's fairly straightforward. I'm just following the framework guides here. So I'm just gonna npm install the stuff that we need, then init the Tailwind CSS file, and then in the config we are going to use the source directory here. So we're just gonna remove the rest which we don't need, and then we're gonna change the global CSS to import the Tailwind stuff and then delete the other one. And inside our index TSX, we are going to remove the rest of the styles. Actually, we can remove basically all of these elements because I'm just going to give you a little template to work with in a second. So just remove all of these and remove the rest of the class names from the footer. I also directly want to install the Morpher.io DD abstraction kit, which is our npm library that depends on, or this is a fork from Candide, and just extends it with this data dependent calls that you can make. When we restart our dev server, then we can see the very basic scaffolding doesn't have a lot of design. Just maybe center it for now. Give it a class name, a container, and center it in the center. And then the connect button, also center it with this CSS. I'm not going to go too deep into the CSS. It's a Tailwind, and you can use any CSS framework that you want. I'm just going to provide you with some icons. The icons are actually generated from ChatGPT, so I'm not going to say I'm an UI or UX artist here, just trying to get things done. And the first thing that I want to do is use the account hook to see if an account is connected. So if you have an account, then we have this little test, and if there is no account connected, then these elements are hidden. So inside those, let's show our silver coin, just to show something for now. And let's make this centered. And then let's take care of the first big part, which is calculating our smart wallet address. So within the ERC-721 account abstraction space, you need to calculate a smart wallet address. And to do that, we are going to import our smart wallet from our DD abstraction kit. It's the basic functionality from Candide as well to calculate this. And we have two entry points right now which are supported, entry point V06 and entry point V07. And if the user connects an address or the address changes, let's use this use effect hook from React to set the smart account based on a safe account. And you see here the import is from DD abstraction kit, but it's the wrong import. What you actually would need to import is from our DD abstraction kit. When you go into the abstraction kit, then you see the V002 and 003 that corresponds to entry points 06 and 07. So if I'm going to import the safe account V02, then I'm going to create a safe account for the entry point V06. And that is going to initialize a new account. And from there, I'm getting the address, and then I can show it over here. So this is my smart account address. Now let's calculate how much gas balance this address actually has. And we can use the use balance hook from WagMe here. And I'm just going to use the smart accounts or safe accounts account address. Just have to give it here the type as a 0x string, otherwise TypeScript will complain. And we are just going to show the balance over here. If we have that fetched, then we are going to say it currently has this kind of value in Pol token or Pol currency. This is a little bit tricky because this one returns a formatted property, but this formatted property is deprecated. So I'm just going to use the format units functionality from Veeam here to format the value with the amount of decimals. And I can only do that if the value is actually not undefined. Otherwise, I'm just going to display 0 here, or maybe loading or something. Now, the next thing I want to do is, because the smart account will be initially empty, so I want to have a simple method to top it up. Instead of going into your wallet and then selecting the address and then sending something there, I'm just going to build a functionality here that you can press a button and top up your wallet. I'm going to use a simple icon from Flowbyte, this cache icon here. I'm going to add it to our icon library, maybe as an icon cache. And then, yeah, I'm not going to bother overriding any of these. Just going to use this icon here. It's enough for our use case. And there's the icon. Maybe want to move it up a little bit. So when we hover and click it, something happens. Let's move it over here. And then we need to somehow send a transaction. Now that happens obviously on click. We need to send a transaction, but where's the transaction coming from? The transaction is also coming from a WagMe hook, the use send transaction, and that one gives us back this send transaction functionality, and we're gonna send it to our smart account address with 100 gas tokens for now, which is more than enough to cover for one NFT that costs some 87 point something. We're going to use that use send transaction hook, and when we click the button, then MetaMask here will pop up and will ask me to send a transaction. Now the next thing is our NFT, and to get the actual coin balance of our NFT, we can use another hook from WagMe, which is the use read contract hook, and this one needs a couple of things: the ABI, the address, and the function name, as well as the argument for balance of who is the one that we want to have the balance of. So where's the contract address? Something we need to fill in. Then our ABI from the silver NFT is something we need to get. The balance of function is clear, and our account address is also clear. Now, the token address is something I want to add in the environment variable, and I'm just going to copy it over from the deployment. The silver NFT is something we can import from our out directory in our contracts directory. So I'm just going to import that silver NFT from our out directory. And then I have to give this as a 0x string, otherwise Veeam doesn't like it, or WagMe doesn't like it. And then we can get the data for this and just say if it's fetched, then get the data as a toString, and if there is no data, then just output no. So we currently have no NFTs, and the next thing we want to do is mint one NFT. Now that you've reached the last part, and probably the most important part, that is the minting. Now, before we actually mint an NFT, I want to use the Oracle data preview to know how much value we need to send to our NFT contract. There is a specific preview Oracle data endpoint, and I'm going to provide you with a function that you can easily use in your own projects. Then we are going to fetch and display the fee, how much it costs to actually get this Oracle data. Then we are going to create a transaction, that is the call data for safe mint plus the value for our safe account. Then we are creating a user operation. Then we are going to sign this user operation. Then we are going to send the user operation and display the user operation hash that we get back from the bundler. And as the very last part, we are going to open our NFT on OpenSea and see if everything works. Just gonna add a new button, give it a nice design from Flowbyte again, copy this over, and then we can work on the functionality for our minting. Let's add some distance here to the upper element, and let's take care of finding out how much actually silver costs right now. What I'm going to do here is provide a preview data function that gives back timestamp in milliseconds when this was fetched, a price in decimals, and a value. And what it's going to do is it pulls our preview API from our bundler to get the current data unsigned for a specific market. And so it's an approximate data that you can use to calculate how much a transaction value needs to be set in order to go through. And you can download this function. What it does is it's basically starting a timer against a fetch request against our Oracle bundler. You can also take this URL out of the environment variables, but for now, it's just going to hard code it, and it's going to send off a post request as a JSON against the bundler, and the post request body is the ETH preview endpoint. So it's going to take the feed ID and feed it into this fetch request. And let's just have a look how this looks like with a console log before we continue. Also catch the errors if there are any. And then set the interval to the interval that we want to have in our use preview API polling hook that we just created. And if it's going to deregister, then we're just going to clear the interval. And we're going to update the use effect if the feed ID or the interval changes. Now let's use that hook in our index.tsx function, use preview API polling, and let's use that, for example, for our poll feed. Let's have a look how this looks like. Copy this feed ID, paste it, and let's have a look at our console. There's the result. Now the result is our encoded element with the first part is the timestamp, then we have the decimals, and then we have the actual number. So we need to decode that, and I'm going to provide you with this decode function. Let's go through that together real quick. It's a decode hex string, and all it does is it's slicing up the hex string into the first 12 characters, and then the next one for the decimals, and then the last part for the price. So let's use that over here and then set our data with the decoded hex string, which is the JSON result. And then we can use that over here, that price preview, in our TSX index.tsx function, because we want to know how much we actually have to mint one NFT for. So currently our poll data is 0.36201 in dollar. And then we use our silver feed and divide it by the poll feed, but only if the two are actually set. Otherwise it's just going to be loading or something. So what we have to provide to our value to send the transaction is 87.46, 87.44, that's live ticking. And then obviously we also need to add in our prices for actually fetching that feed. So the user also needs to pay for that. So we need to fetch that somehow. It's not hard coded. These prices can change, but we can use the read contract hook again from WagMe to get the contents of the prices mapping from our Oracle entry point for that particular feed for the data provider. So we're gonna import the prices Oracle API again from the out directory later. Then we have the function name is the prices, which is the getter function for the public mapping. And as arguments, we need to give it the provider address and also the market ID which we want to use. And in this case, we're just going to use one of them. Normally you have to use both of them. So both the crypto Pol and the commodities XIG added together. So let's import that ABI, or that actually JSON artifact. And let's see if we can display these prices here when they are fetched. We have to use the format ether function from Veeam. And then we get back plus 0.25 Pol, which is the current price for our commodities. Now let's go on to the actual mint functionality. That's a little bit more tricky. First, we have to create a call data for our save mint function in our NFT. Then we have to add the exact value for minting, plus a little bit of buffer because that value might gonna change. Then we have to create that save mint transaction. Then we have to sign that user operation. And then we have to convert that signature into an ERC-721 UserOp signature. And then we have to send it off. And then we can have a look in Jiffyscan if the user operation is actually sent correctly. Now, all of that we can only do if there's a small smart account actually set and if the address is actually connected. So let's get that out of the way. And then let's create the call data. So this mint function selector, we can use the get function selector function here to create that function selector. And then we can also use the create call data function to get that mint function selector, and then also give it the ABI, which is one address, and then we give it the smart account address. So we are going to call save mint with the smart account address. Next, we are going to add in the value that we need for our function call. And that is our price preview from Pol. Well, our price preview from silver divided by the price preview from Pol, plus a little bit of buffer, plus the data. So in this case, it's the data price. And then we are creating this save mint transaction. That is to our token. The value is that value times a little bit of buffer times 110 to the power of 18. And then the actual data is this mint transaction call data, which is going to call save mint address, the function selector, and adding in the account address as an parameter. Now let's just double check if the value here is correct after console logging. And that's 87.34. That looks correct. So let's continue with creating our user operation. To create this user operation, we can use the smart account create user operation function. And over here we need an RPC endpoint, which we can get in a second. We need the mint transaction, and we also need the bundler RPC. The bundler RPC is something we can provide in the environment files, which is oracle-bundler.morpher.com/RPC. And for the RPC endpoint, for the actual node that is used to calculate the gas, we can use the public client. And for that, we have a use public client hook from WAGMI. Not ideal because it's going to increase the bundle size considerably, but for this example, more than enough. And you can use any RPC that you want here, just using the transport from WAGMI that is already in our Next.js application. And then let's see how this user operation looks like. The user operation looks like this, and it also has a data requirements array. And that one is important for our bundler, the custom bundler, to actually inject values for that array into the UserOp before this one gets mined by the entry point. Then we need to sign all of that. We need the domain and then the EIP v6 safe operation type. Then we need to extract the sender of our UserOp. Then we create the object for our safe user operation. That is our UserOp, our entry point, valid until, valid after, and the sender. I'm gonna add this in a second. Forgot this here, and then we need to sign that. We also need the wallet client. We can use wallet client hook for that. And then we add in the domain, the types, and primary type is a safe op in this case, and the message is our safe user operation. The domain will not add up because the chain ID needs to be a 0x string again. You can copy this here. It doesn't like it because I forgot the safe as the sender. And then if we sign this, then we get a signature request against MetaMask or against your wallet, whatever is connected. And then we can convert this into an ERC-721 UserOp signature. And we can use the safe account.format EIP signatures to user operation signature for that address, for that signer address, this signature, but this time a string. Let's have a look how this looks like. So this needs to have the signature attached now. You can see the signature there. And now we can send it and see if we can actually mint an NFT for our safe wallet. So we can use the smart account send user operation with the UserOp against the bundler. And then let's have a look how the UserOp response user operation hash looks like. Let's mint that. Again, the signature request, the UserOp, and the operation hash, user operation hash. We could go to Jiffyscan now and see that, or you just open your safe account, go to the assets, the NFTs, and then you can open your new NFT directly on OpenSea. So the question is, how is that different from a normal user operation? In a normal user operation, you have a user that sends a UserOp, and then that gets to the bundler, and then the bundler is going to add this to a bundle transaction into the entry point. Now with a data dependent operation, you have the normal UserOp that goes into the bundler, but the bundler sees that, wait a second, there's something that needs to be injected as a price point, and then he's going to inject another UserOp, but as the data provider into this bundle transaction to the entry point. And then that one is going to update the Oracle entry point, and your user operation is going to just normally interact with your smart contracts, which are then reading out of the Oracle entry point. Now, this is how it works. I hope this tutorial was helpful to you to build your own Oracle implementation. If you want to get in touch with us, feel free to join currently our Telegram, but whatever community we have, we're going to update our website, and happy building.